Assalamu alaikum. Bismillahirrahmanirrahim. Welcome to our JNCIS-SP Service Provider Routing and Switching Specialist this course. Today we discuss provider pricing. This topic is under service provider switching. Okay, so let's start provider pricing. Okay, first go to our today's slide. Service provider switching. So our today's topic, provider pricing, network concept. See here, customer base network site one. Consider it's a customer. One customer is here, and another customer is here. This customer is connecting with single service provider. Okay. Normally, service provider connect the connectivity with router. Just service provider may have switching network also here. Just consider they are connecting with the router interfaces that can be through the switch, or it can be from a direct router port to customer switch. Okay, and this side also have router, and this will be the connectivity from router to customer switch. Okay, in this case, customer bridge network or customer site one is directly connect with service provider, and service provider giving the site one specific IP address for communicating this subnet, and for customer site 2 they will also keep the same. That means this service provider will work as a layer 3 environment. Okay, as a layer 3 environment. If you consider service provider will work as a layer 2 service provider, so it can also possible. Okay, so consider this service provider. It can be entity and service provider, or it can be any service provider, and multiple customer basically connect with service provider. Consider here, this customer need 100 billion for connecting multiple site or multiple services. Okay, this customer need like 100 billion. So consider this service provider have consider 1000 customer. Okay, 1000 customer per customer need 100. That means this service provider need 10,000 billion. 10,000 villain. But we know the villain is basically limited. Okay, so villain ID, we know the villain ID is 12-bit. So in that case, we'll get maximum 2 power 12. That means maximum villain will be 4095. So 0 and 4095 will be reserved, and 1 to 4094 you can use in your production network. So that will not fit your requirement based on customer. Okay, so we need alternative solution. We need alternative solutions. So what can be the alternative solution? You can consider MPLS network, or you can provide like VPLS or L2 VPN. Uh, that can be one solution, or you can consider Q and Q. That will be another solution. So today we discuss provider pricing. Okay, provider pricing also one solution for this problem. Okay, so let's go. Customer base networks. Okay, so 800 to 1 Q VLAN is called the customer local base network. We know 801Q. 800.1Q means the port is trunk port and multiple VLAN will be allowed on that port. That is 800 to 1Q. Okay, so issues with the service provider is scaling for 800 virtual connections, like problems of overlapping VLAN ID between service provider customers. Okay, in customer side, they are using like range of VLAN. In the same time, service provider also use the same VLAN. Okay, so service provider layer 2 domain and customer layer 2 domain is directly connected with each other. So there will be have some problem. Okay, if customer have certain problem in certain VLAN, that will be forwarded to service provider network. Okay, that's the problem. So service provider presents learn and store customer media access control, that is MAC address. That is true. Okay. Service provider network must be aware of customer bracing, that means spanning tree and VLANs. Spanning tree and VLANs. You know the spanning tree is multiple type. So customer can use RSTP or MSTP or like default STP. And you may use MSTP in your network. So there is variation of spanning tree. So in that case, there is dependency on spanning tree protocol. Okay? So you need to consider with your customer also what will be the best suit for your network. This is another challenge. Okay, provider based network. So service provider offers LAN service through the service provider network. Just consider here service provider one bridge network, service provider one bridge network. So this is the customer one, and another service provider is here. Another service provider is here, service provider two. Now customer need. Now customer need. This is site one, and this is the another site. Okay, customer need to communicate from site one to site two. Consider here, customer want like this. Um, they want single VLAN from service provider like 110. Another side, they use same VLAN 110. Okay, so this is single VLAN. For this VLAN, service provider create this on their base network and allows those VLAN also request to service provider 2. Please create VLAN 110 and allow your base network so that customer side 2 can communicate from site 1. So in that case, the difficulties is customer choose the VLAN ID. You have service provider 1, make sure this VLAN ID is free or not. Also service provider 2. This is the another dependency. So in that case, it's very difficult. It's very difficult to ensure the customer requirement. Okay. So in that case, we can divide the VLAN tag or VLAN ID in two different types. One is S VLAN and another is C VLAN. What is this meaning? S VLAN means service VLAN. C VLAN means customer VLAN. So service provider offers LAN service through the service provider network. Is outer tag, that means service VLAN, that means edge VLAN tag represents a customer 4094 possible. That means in service provider 1, they use single VLAN like VLAN ID 100. Against this VLAN, against this service provider VLAN, customer use uh, customer can use 124094 VLAN. 10124094 VLAN against single VLAN. Against single VLAN. This is the concept of C VLAN and S VLAN. So consider here service provider 1 use 100 VLAN for this range. Service provider 2 can use different VLAN like 101 for supporting this range 10494 for single customer. So in that case, per customer can use the range of VLAN. The range of VLAN will be 124094. But in service provider perspective, they are assigning only single VLAN. This is called the edge VLAN. Okay. So this one is the outer tag, and C VLAN is called the inner tag. So this is the concept of provider bridge network. Say here, the service provider and the customer use unique spanning tree domains. Okay, this enable VLAN translation between service provider bridge network. So consider here, service provider 1 use 100 VLAN. This is trunk port. You allow this VLAN. Service provider 2 use 101 VLAN. If one request is coming, from 110 like this, okay, just taking the request 110 trans and convert it to 101. If getting 101, this router rewrite 101 to 100. So in service provider, between service provider, you can translate the VLAN if necessary. Okay, if service provider 1 use a different VLAN, service provider 1 and service provider 2 use different VLAN, you can translate from one VLAN to another VLAN, or you can say you can rewrite. So they have this facility in provider bridge network. Or consider service provider 1 use 100 VLAN, service provider 2 also use 100 VLAN because this VLAN is free. So in that case, no need translation. Okay, just allow this VLAN and configure this port as a trunk port. So this is the concept. So move forward. What is provider bracing? So enable service provider to offer the equivalent of separate Ethernet LANs to their customers. Easy for customer to understand. Easy for the service provider to provision. One VLAN equals one customer. Require the use of two stacked VLAN tags. C VLAN for basically customer, and S VLAN basically for service provider. S VLAN basically for service provider. So in layer 2 frame, they have both VLAN tag, S VLAN tag and C VLAN tag. So S VLAN tag S-VLAN tag protocol identifier use the 16 bits default, and C-VLAN tag also use same 16 bits. This is the structure basically of C-VLAN and S-VLAN. But if you see the VLAN identifier will be the 12 bits. That will be same as before. Okay, so this is the topology to understanding provider bridge network. Okay, see, this is the customer bridge. That means customer switch. Another side, this is the customer bridge, basically the customer switch. And here example, they are taking MX240 router, MX240 router. So this is the customer is, this is the customer is, and this is the provider bridge. Okay, this is the loop provider bridge network. So this router is called the PEB, provider as bridge, provider as bridge. Okay, so provider bridge makes several different adjustment to the VLAN stack. That means uh, they uh, they can do multiple tasks basically. You can push one VLAN to another VLAN. That means you can insert just taking one VLAN, and when you forward this prime to another sources and just swap the VLAN. So there is basically push. The action will be push, pop, swap, and last one is rewrite. Okay, push means add an outer tag. That means you are just taking inner VLAN. You are just taking the inner VLAN. Inner VLAN is coming from customer. You are just providing the VLAN towards the customer. So this is the inner VLAN. Just taking the inner VLAN and push that VLAN to translate the another VLAN and assign the outer tag VLAN ID. That is called the push. Or you can also use pop method. Pop method basically used for removing the outer tag. Swap means just taking the one outer tag with new one. This is called the swap. Okay. And pop means remove the outer and inner tags. Both will be removed. Push pop add two tags, inner and outer. Swap means swap the inner and outer tags with new ones. Pop swap means pop the outer tag and swap the inner tag. Swap push. Swap means the adding the inner tag and add an outer tag. Rewrite VLAN means you can say just swap one VLAN to another VLAN. So this is the VLAN tag operation or VLAN tag action. Okay. So see here, customer forwarding the VLAN ID is 100. Forwarding the VLAN ID is 100. Receiving this VLAN as the inner VLAN in MX240, and the outer VLAN is S VLAN, the VLAN ID is 200. That translated to again to 100 VLAN. So here is VLAN, here is VLAN, just taking inner VLAN 100, taking inner VLAN 100, swap them to 200 and again swap to 100. So service provider basically customer use 800 to 1 Q tag frames. That means CVLAN to connect to the remote site while the service provider network is transparent. SVLAN tagging of the customer frames during transmission across the service provider network provides transparency. That means when receiving this frame in MX240, they insert both tag. C VLAN tag and S VLAN tag. C VLAN tag is 100 and S VLAN tag is 200. Forwarding this frame from MX240, this PEB to another PEB, they just taking this VLAN tag C VLAN 100 and the S VLAN is 200. Again, just reverse this process. This is the basically same frame processing process. Okay. C VLAN basically same. And here is the example. Just say here C VLAN ID is 100. So MX240, consider this is your interface between your service provider and different bridge network or different router. So this router is acting as a switch basically. So consider this interface is directly connected from MX241 to 242, or you can say provider is bridge A and provider bridge C. This is the directly connected interface, and say here the unit dot one. So dot one this interface just taking this frame, and the customer VLAN ID is 100 and push the VLAN to 200. That means push to VLAN to S VLAN. And this service provider bridge network know the VLAN ID 200 and getting this MX240, that means provider bridge D, they are taking C VLAN tag and S VLAN tag, and again they are making the reverse process. Okay, this the another interface, and both S and C. Finally, they're making this port is basically Swiss port. They're making the sub interface to travel MX240 to the customer base. So this is all about regarding SVLAN and CVLAN. So now we are going to the Q&A section. What is statement-based defines provider-based networks? Provider-based networks are defined the standard for stacking VLAN tags. Standard for stacking VLAN tags. VLAN tags have here we learn two types of VLAN tags. One is C VLAN tags and another is S VLAN tags. C VLAN tags is for customer base and S VLAN tags is for the service provider base. Okay. What does frame processing contain? Frame processing content basically address. This address is basically the MAC address and the interface, outgoing interface. Configuring a provider base. How to configure provider base? Considering customer side and service provider side. Okay. First, Junos interface is sometimes referred to in shorthand as physical interface. That means physical port, logical interface, logical unit, interface family, protocol. You know this. Okay. How to write physical port, their logical interface, that means unit 0, 1, 2. This is the logical interface. Family means you are configuring this interface as a layer 2, layer 3. Okay. So we're configuring this interface as a layer 2. That means family base, interface mode access, and this is the VLAN ID. This example is basically configuring one single interface as a access mode, and associate VLAN to 100. Okay. Bridge domain modes. Bridge domain can learn into different modes. One is independent VLAN learning, that is called IVL, learning domain for each VLAN. And another is shared VLAN learning, that is called SVL, single learning domain shared by all VLANs in a bridge domain. Okay, so dual stack VLAN configuration. Dual stack VLAN configuration. That means consider this interface is connecting with the customer bridge. Okay, so customer sending this VLAN ID list like 101 to 114, and this port is trunk port, but in service provider, side, they are using 200 VLAN against this range. So in that case, this range is called the inner VLAN, and the service provider VLAN 200 is called the outer VLAN. Inner and outer, both in same single interface. So in that scenario, or this configuration is called the dual stack VLAN configuration. Dual stack VLAN configuration. For dual stack VLAN configuration, you have to configure the interface as a flexible VLAN tagging, not VLAN tagging, flexible VLAN tagging. So this is the one example. Consider, and this is the customer. Customer can use VLAN range, VLAN 1 to VLAN 4094. Okay, this is the provider based router, act as a bridge. Say here outer VLAN 200 and the inner VLAN will be 1 to 4094. Okay, so the S VLAN is 200. So here is one interface Z1 by 1 by 4.1. That means see here the interface is 1 by 0 by 6, 1 by 0 by 6, flexible VLAN tagging, encapsulation, flexible Ethernet services, family bridge, interface mode trunk. The VLAN ID allowed is 200. Just allow the outer VLAN in service provider network. So in that case, you have to create the bridge domain, that is bridge domain customer 1 for customer 1, VLAN ID 200. For for customer range of VLAN, service provider use only single VLAN. So you can say per customer in service provider in per customer use single VLAN. So another interface in PEB, that means 1 by 1 by 4, this interface configuration is like this, identical. That means when I go to my lab, see here, this is basically customer router, and this is the customer router. Okay, this is provider base 1, that means provider base network 1 or service provider 1, and another is service provider 2. Service provider 1 have 3 switches, switch 1, switch 2, and switch 3. And service provider 2 have also 3 switches, switch 4, 5, and 6. So this is our C-VLAN tag. Service customer need 1, 2, 3, 4, 5, 6, 6 VLAN, 6 C-VLAN. Okay, and they are assigning this IP address for the specified VLAN. For service provider 1, they use VLAN 100 for S VLAN, but in service provider 2, they use S VLAN 101. This is different. Okay, so first you have to configure S VLAN bridge, this switch provider bridge network. In provider bridge network, they have to allow the outer VLAN and the interface The interface will be flexible VLAN tagging, and encapsulation also will be the encapsulation flexible Ethernet services. And you have to create the outer VLAN. You have to create the outer VLAN in MX router. We create VLAN ID like this. Set bridge domain, set the name, and set the VLAN ID. And allow this VLAN ID in bridge or switch interfaces. That means, consider here, um, this is your service provider network switch, switch 2 and switch 3. This device not directly connect with the customer. Okay, like similarly switch 4 and 5, this device is not directly connect with customer. This device is internal in service provider 1 and 2. Okay, in that case you have to configure this port as a trunk port and allow this VLAN. Okay, similarly others port. So how to configure this one? So let's start like switch 2. In switch 2, say here, in switch 2, just go to any any one interface like Z0 by 0 or Z0 by 0 by 1. Edit interface GE 0 by 0 by 0. See here, the interface is flexible VLAN tagging. This interface encapsulation is flexible Ethernet services. Unit 0, this interface unit 0 family bridge. That means this port is acting as a layer 2 port. The interface mode is trunk. That means this port allowed multiple VLAN. I allowed here the VLAN ID is 100 because I use the S VLAN 100. That's why I configure or allowed the VLAN ID list 100. So this is the sample configuration in service provider switch port. Service provider switch port. You can just simply think, and this is a switch. You need to allow multiple VLAN, and this switch is connected with another switch. So you have to configure this switch as a trunk port and allow the specific VLAN. The extra configuration is this flexible VLAN tagging. When you configure C VLAN and S VLAN scenario, in that case, you have to configure the layer 2 interface like this. Flexible VLAN tagging, encapsulation, flexible Ethernet services. Okay. Similarly, if you want to see the interface 1, you can get similar configuration. Okay. But in 4 and 5, similar configuration you get from here, display set. See here, flexible VLAN tagging, encapsulation flexible Ethernet services, and allowed the VLAN ID list. This configuration is different, but this is identical. So in switch 4, we get similar configuration. In switch 4, the connected interface is 0 and 1. So 0 and 1, flexible VLAN tagging, flexible Ethernet services, interface mode trunk, and allowed the VLAN ID. So here allowed VLAN ID is 101 because service provider 2 use VLAN ID 101 as a VLAN. That's why I allowed the 101 VLAN. Okay. So this is basically the configuration of S VLAN bridge configuration. And this is the port configuration and how to create the VLAN. This is the command. Set bridge domain, and the bridge domain name is customer BDs. You can set any name here, and the VLAN ID is 101. In MX device, we creating VLAN with this configuration. Okay, tunneling all VLANs. How to tunneling? How to tunneling all VLANs, which is getting from customer, which is getting from customer. So this is our PEB switch, PEB provider is bridge. Provider is bridge, and the customer bridge is connecting. The interface is this one, Z-1 by 0 by 0. This interface is the connected interface between PEB and the customer bridge. So in that case, G1 by 0 by 0, this port will be the layer 2 port. Family bridge interface mode will be access, and the VLAN ID will be the specific VLAN, and this interface is 10 by 4. That is mm, service provider to different MX devices interconnected port. This port should be trunk, and the allowed VLAN will be 200. Allowed VLAN will be 200, which is attaching here. Okay, and this is the way to create the VLAN ID. Okay, way to creating the VLAN ID. So you can consider here VLAN ID 200 is coming here. You are just enabling the trunk port, allow this 200 VLAN, and coming here this 200 VLAN from customer is. This very simple. This device work like a switch, layer 2 switch. That's it. No difference. And the another example, tunneling a range of civilian. So if you consider you have range of VLAN, the range can be VLAN ID 1 to VLAN ID 4094. So consider this is the customer interface connecting with PEB. So this is the sample configuration. This is the range basically. Family bridge, interface mode trunk, and this is the VLAN ID list. VLAN ID list. So here, if you see another interface 1 by 0 by 4, 1 by 0 by 4, this interface will be flexible VLAN tagging. Unit 0, VLAN ID 200. This VLAN ID basically the outer VLAN, and the inner VLAN will be inner VLAN ID list will be customer forwarding VLAN list. Okay, and this is the bridge domains. This basically coming from customer. This limitation is this approach creates one bridge domain for is CVLAN. One bridge domain for is CVLAN. This is the limitation. So this is one way tunneling all CVLANs. That means customer sending single VLAN. So this is the process. Customer sending multiple VLAN or range of VLAN. So this is the process. And tunneling a range of CVLAN. So this is the complete configuration. If the destination MAC address is unknown, the frame is flooded out all interfaces, the normal scenario. PB encapsulation VLAN bridge 1 by 0 for VLAN ID 111, for VLAN ID 112, for VLAN ID 113. They are configuring for VLAN. Okay. Show bridge domains, BD, VLAN ID. The bridge domain is BD. Under BD, they are mentioning the interface. Which interface is participating? 1 by 0 by 0, 111, 1 by 0 by 0, 100, 112, like this. Okay. So this is the process. Input and output VLAN maps. You can also map input VLAN with the output VLAN. This is the another process. Okay. So network to network interface configuration. If you consider multiple service provider 1 is here and another service provider is here. In service provider 1, they use outer VLAN is 200, but in service provider 2, they use the outer VLAN is 300. Outer VLAN is 300. So in that case, the VLAN ID is different. Outer VLAN ID is different. Okay. In that case, you need to rewrite. Rewrite. So SVLAN bridge, that means this SVLAN bridge is this one. This one getting the VLAN ID. Consider here the VLAN ID. First get outer VLAN ID is 300. 300 is coming here. 300 is coming here as an inner VLAN, but here in PBN1 there is no the VLAN ID 300. So we need to rewrite this one. If inner VLAN is coming 300, that VLAN will be translated to the VLAN ID is 300. 200, sorry, 200. And this VLAN ID is already allowed and passed towards the customer. That means they are taking one VLAN and translate to another VLAN. This is called the VLAN rewrite or translation. Specify the expected inbound as VLAN ID. The VLAN ID is 300 and the SVLAN ID to be used within the PBN, that is 200. The translation is bidirectional. The translation is bidirectional. So if getting the VLAN ID is 200, here getting the VLAN ID is 200 as the inner VLAN and rewrite to the VLAN ID is 300. So this is the process to translate one VLAN to another VLAN. One VLAN to another VLAN. This is basically MPLS concept. MPLS concept. And this is a virtual private LAN service, that means a VPLS. Point to multipoint. Point to multipoint. So consider here VPN A, site 1, this is site 2, this is site 3, site 4. They will communicate from one site to 3 different sites through VPLS if this MPLS backbone works perfectly. Okay, check your understanding by the given example. What tag pops before the map table lookup when the bridge domain is configured for VLAN ID none? VLAN ID none means basically C VLAN tag. C VLAN tag. What are the fields from show interface command to show the VLAN operation that the interface performs? Interface performs mainly in field and out field. In VLAN, inner VLAN and outer VLAN, basically. So that's all. So let's go to our lab and checking step by step. Checking step by step. See, first, consider here. Now, first, I'm in Swiss 1. Swiss 1. Swiss 1 have two interface. One interface is 3. 3 is connected with direct customer and 0 is connected with their service provider backbone. Here, the S VLAN is 100. Here the edge VLAN is 100. So in that case, we need to configure multiple things. We need to configure multiple things. Step one. Step one. Consider, see here, the C VLAN is 110 to 115. So you need to create 6 C VLAN. You need to create 6 C VLAN. How to create? Set bridge domain. The bridge domain name for VLAN ID 100, the bridge domain name is this. You can set another name. This is basically user defined name. The VLAN ID is 110. So this is the line to create the VLAN ID 110. Similarly, create 111, 12, 13, 14, 15. So our 6 VLAN creation done. 6 VLAN creation done. Okay. Next, after creating those VLAN, you need to allow those VLAN to switch 1 G0 by 0 by 3. So go to this interface G0 by 0 by 3. Flexible VLAN tagging. This interface is flexible VLAN tagging. Next step, allow the VLAN ID in customer connected interface. So interface 3 allowed the VLAN ID 110, 111, 112, 113, 114, and 115. Consider here 110. So 110 encapsulation VLAN bridge. VLAN bridge. They are working. We know about interface bridge. Interface bridge means if you add multiple interface in a single bridge, that means those interface act like layer 2 switch port. Act like layer 2 switch port. You can also do with VLAN ID. Okay, you can also do like this to tagging the VLAN ID. So here the VLAN ID is 110. You just adding the encapsulation VLAN bridge. The VLAN ID is 110. If this customer, if this customer forwarding any frame touching the VLAN ID 110, they will, this interface can receive. This interface can receive. Okay. Okay. And this interface is the service forwarder backbone interface that is connected with another switch, that is switch 2. So when receiving this frame in G0 by 0 by 0, they're taking the VLAN ID is 110 as a inner VLAN, 110 as a inner VLAN, 110 as a inner VLAN. The outer VLAN will be the 100. As said, the outer VLAN ID is 100. So every VLAN ID taking the outer VLAN 100, 112 taking the outer VLAN 100, 13 100, 14 100, 15 100. Okay. So we're just mapping which one be the inner VLAN and which one be the outer VLAN. Okay. Which one be the inner VLAN and which one be the outer VLAN. So this is basically the mapping. Inner VLAN, if one inner VLAN 110, the outer VLAN will be 100. So for customer 1, they are using 6 different VLAN. For 6 different VLAN, in service provider in, they are using single VLAN, single S VLAN. This VLAN is called the outer VLAN. Okay, this is basically called the mapping, inner VLAN and the outer VLAN. Okay, and finally, when we add the breeze domain, see here, in breeze domain, just attaching the physical subinterface, in a breeze, in a single breeze, so that they can communicate with each other as the layer 2. Okay, so in Z0 by 0 by 3, we are using here dot 110. We use here 110 VLAN is VLAN breeze. So this interface breeze with the outgoing interface Z0 by 0 by 0, that is dot 0. Dot 0 means in dot 0, say here in dot 0 we are mapping 110 to 100. So consider these two. We are just creating here one sub interface for 110. Also creating another sub interface is for 110. This two logical interface creating a breeze. This logical interface creating a breeze, so that they can just taking the inner VLAN and passing the outer VLAN through the outgoing interface. So this is the concept basically in Swiss 1. Here basically we are doing 3 steps here. Number 1, creating the VLAN. Number 2, creating the multiple unit in incoming interface and the outgoing interface. Also mapping the VLAN, inner VLAN and the outer VLAN. And finally adding those sub interface in breeze domain. Okay. So this is the configuration of Swiss 1. But in Swiss 2, this is very straightforward. Just allowing the VLAN ID 100 in Z0 by 0. Also allowing the as VLAN ID 100 in Z0 by 0 by 1. This is very straightforward configuration in Swiss 2. Swiss 2
I have one
configuration is
query in Susan.
okay. Mhm.
The last portion. Sub interface G0 by 0 by 3 getting breeze with Z0 by 0 by 0. That means
Mhm.
Z0 by 0 by 3. We transfer 110, 111 children. Z
Yeah.
0 by 0 dot 0 dot 1. I didn't understand that one's last
Okay.
3 lines.
This one, right?
Yeah,
Okay. So go to the interface is 0 by 0 by 0. See here, the I use here the unit number is 0. I use here the unit number is 0. The encapsulation is what? VLAN breeze. Okay. So
yeah,
here we use the mapping. If I getting the inner VLAN 110, outer VLAN will be the 100. Outer VLAN will be the 100. So this is basically a logical interface. This is basically a logical interface for VLAN ID 110. So just you can consider MikroTik. My MikroTik, it's a router. This I have multiple routed interface. We're just creating a breeze interface and adding the physical L3 interface under the breeze. So in that case, under the breeze, every port will work as a L2.
yeah,
Okay. So consider here, you are just creating the logical interface. We're just creating the logical interface. The logical interface is this one, J0 by 0 dot 0. And this logical interface, you are just mapping inner and outer VLAN and considering this logical interface is a VLAN bridge. The type is VLAN bridge or encapsulation is VLAN bridge. Okay. In the similar way, this is the logical interface C0 by 0 by 3 dot 110. This is the logical interface. This logical interface encapsulation also the VLAN bridge and setting the VLAN ID 110. So consider here customer sending frame attaching CVLAN 110 attaching CVLAN 110. Okay, so
Yeah.
they are just tracking this frame in Swiss 1. Okay, so when Swiss 1 forward this frame to towards Z0 by 0 by 0, Z0 by 0 by 0 don't understand the VLAN 110. This device only understand is VLAN. The VLAN ID is 100. So in that case, I asked Swiss 1, if you get the VLAN ID 110 as the inner VLAN, please
Okay.
convert it to 100 as the outer VLAN. Okay, convert
Yeah, I
it
got it.
to the VLAN ID is 100 as the outer VLAN. Okay, this is basically happened when both will be in a single bridge. Both logical interface will be in a single bridge.
Single view.
Consider here, both
Yeah.
logical interface is in a single bridge. See here, 110. Both logical interface in a single bridge. That's why they are doing this task.
Yeah. Now got it. Got it.
Okay. So I think Swiss 1 configuration is okay. Then go to Swiss 2. Swiss 2 configuration is very straightforward. Just creating the VLAN ID 100. Very simple. And you were just allowing the S VLAN, which is used in service provider bridge network. So interface will be flexible VLAN tagging, encapsulation, flexible Ethernet services. Interface will be trunk and you have to allow the VLAN ID. Your VLAN ID is as VLAN ID. That means VLAN ID list
Only
is
100.
100. Perfect.
Yeah.
And this configuration also the identical. Same thing will be happen for Z0 by 0 by 1. Just tracking the SVLAN and passing those SVLAN to another switch.
Now the here there is
Okay?
trunk mode. Basically, trying the
Yeah.
villain
Basically trunk.
from the next
Hmm.
switch.
Okay. Okay. Now going to next switch, that is switch 3. In switch 3, they are taking the SVLAN tag. Receiving interface is Z0 by 0 by 1. So in Z0 by 0 by 1, basically the configuration is identical like switch 2. Is there any difference?
No.
No. Just creating the VLAN and configure the trunk port allowed the VLAN. Simple task. But in switch 3 outgoing interface, the interface is Z0 by 0 by 0. Basically here the task is same. Mm, Allowing
But
the
we
VLAN
get
ID interface is trunk, but the difference is, but the difference is,
multiple service provider.
consider in switch 4, they are getting the VLAN ID 101 as a inner VLAN. As a inner VLAN because provider bridge to use is VLAN, the VLAN ID is 101. Okay, so this is trunk port. They are sending the VLAN ID 101. this switch receiving the VLAN ID 101. If this switch receiving inner VLAN 101, they translate this VLAN ID 101 to 100 so that they can pass the VLAN ID towards the customer. Clear?
Yes,
This
basically,
is the
the whole scenario
and
works like this
rewrite
in MPLS format.
translation, VLAN translation. Getting one VLAN, translate to another VLAN.
Another filler.
Clear?
In different service provider, we use VLAN relay. That means that translate feature, right?
Yeah, right. If uh, we consider different service provider or multiple service provider, in that case, uh, hmm, we
Our
need
as VLAN
VLAN
will be different.
translation. And VLAN ID, if VLAN ID is different. Consider service provider use VLAN ID 100 as a VLAN. In service provider 2 also use VLAN ID 100. So no need
Then we
translation.
do, then we do that
No
same
need
thing
translation.
as we do in system.
No
Only
need
pass
this
that
line.
VLAN. Okay, okay.
No need this line. Okay. Okay. So this is very straightforward. And switch 4. Switch
Same thing.
4 basically receiving VLAN ID. They're sending VLAN ID 100 basically, right?
Yeah.
Similarly, they're sending the VLAN ID 100 as the inner VLAN, but you have to translate to 101 like this. Okay. So how to do this? In interface Z0 by 0, in interface Z0 by 0, so you are allowing the VLAN ID is 101, 101. So you need to rewrite this one. You need to rewrite this one. Brace VLAN rewrite.
101 to 100.
You are getting inner VLAN from VLAN ID, from VLAN ID 100 and two VLAN ID, two VLAN ID will be 101. This is the translation. Getting one VLAN and translate to another VLAN. Perfect. Is it okay?
Yes,
Switch
clear.
4? Clear. Switch 5. Switch 5 is very straightforward. Switch 5 is basically similar to Switch 2.
Switch to.
Basically Switch 2. Just configure as a transport, allow the VLAN. Configure as a transport, allow the VLAN. And this is the how to create the VLAN. And Switch 6 is very identical to Switch 1.
Switch on.
Okay, so this is the basically similar configuration here. So let's place it.
Same.
First, creating the VLAN 100, 111, 12, 13, 14, 15, VLAN ID creation done. So next step, create the logical interface. Create the logical interface 110 and the encapsulation is VLAN brace. And creating also the logical interface for the Z0 by 0, Z0 by 0, and the VLAN ID is getting the inner VLAN 110 that will be mapped with 101 because PV2 use as VLAN as 101 and this is the VLAN bridge. This logical interface Z0 by 0 by 0 dot 0 and this logical interface Z0 by 0 by 3 dot 110 both will be in single breeze. Similar task happened. Okay, similar task happened here. So this is the basically configuration. When you consider multiple provider based network in a your requirement. So this is the example of SVLAN, CVLAN, and this is the example of SVLAN. and this will be the configuration. Okay, I think that's all for today. So any query?
Clear all.
Okay.
Very simple concept. I just uh,
Mhm.
in uh, both client side we have multiple villain, and we
Mhm.
forward this villain through service provider in a single villain.
Single
If
villain.
there are multiple service provider, then we use rewrite feature to
Yeah.
translate that villain from one villain to another villain.
Mhm. One villain to another villain. Perfect. Perfect. Okay. So that's all for today. So next, we will discuss spanning tree protocols. So let's finish.